Hello everyone, myself Lokesh Soni and I am working as an assistant professor in the Akgec EC Ghaziabad in the ECE department. So this is our fourth lecture for the digital system design and the topic of this lecture is binary arithmetics. In binary, the content of this lecture is, first we will take the addition of binary numbers, how we can add the two binary numbers, followed by negative number representation, subtraction of the binary numbers using the direct subtraction, 1's complement, 2's complement and complement for the other number systems. First topic is binary addition, how we can add the two binary numbers. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, but 1 plus 1 in decimal is 2. So the binary representation of the 2 is 1 0. So 1 plus 1 in the binary is not 2, it is 2 in the decimal form, but in binary it should be a 1 0. That is already written it here. So if we want to add 3 1 plus 1 plus 1, so in decimal 1 plus 1 plus is 3 and the binary representation of the 3 is 1 and 1. So if we want to add two numbers and if there is a 3 ones are appear in the addition, then we have to replace it by 1 and 1. 1 is the sum and 1 is the carry. That is already written in this table. As we can observe that 1 plus 1 is 1 0, that means 1 is the carry and 0 is the sum. Similarly 1 plus 1 is 1 1 1, that is 1 is carry and 1 is sum. If we want to add these two numbers, one number is 0 1 1 0 dot 1 0 and second number is 1 1 0 1 dot 1 1. So 0 plus 1 is 1, 1 plus 1 is 1 0, that means sum is 0, carry is 1, carry will appear here. So 1 plus 0 plus 1, again sum is 0, carry is 1, 1 plus 1, again sum is 0, carry is 1. Now here 3 ones are in the addition. So 1 plus 1 is sum is 1, carry is 1 and 1 plus 1 is sum is 0, carry is 1. So this is our final carry 1. So the addition of these two numbers should be 1 0 1 0 0 dot 0 1. So that's how we have to perform the binary addition of the two numbers. Next topic is how we can represent the negative numbers using the sign and magnitude, 1's complement and 2's complement. So for the sign magnitude, if the MSB bit is 0, MSB or fourth bit is 0, it will represent the positive number. If MSB bit is 1, it will represent the negative number. It is already written in here, and 1's complement is nothing but just we have to replace the 0 to 1 and 1 to 0. And for 2's complement, we have to take first 1's complement and just add 1 into a 1's complement. It will give to a 2's complement. That means 1's complement plus 1 is equal to a 2's complement. So how we can represent the sign magnitude? For example, plus 7. The binary of the 7 is 1 1 1. But as I told earlier, in sign magnitude, the fourth bit detects or reflects whether the number is positive or negative. So if here mentioned is it is a positive. So for positive number, the MSB bit should be 0. For positive number, the MSB should be 0. So it will represent the plus 7. And for minus 7, the binary of 7 is 1 1 1. But here the sign is negative. So for the negative number, the MSB bit should be 1. So here it is a 1. So it will represent the negative number. So this is a -7 and upper one is the +7. Now for ones complement, how we can take the ones complement? For example, we have some number like 101. This is some number in a binary. How we can take the ones complement? For ones complement, we have to just replace the 1 with 0 and 0 with 1. So it will become 0, 1, 0. Because we will replace 1 with 0, 0 with 1 and again 1 with 0. So this is our ones complement. How we can perform the 2s complement? So for the 2s complement, either we have to take ones complement of the number and add 1 into it. For example, the ones complement of 101 is 0, 1, 0. Now to take the 2s, perform the 2s complement, we have to add 1 here at the LSB side. So 0 plus 1 is 1, 1, 0. So this is our 2s complement of this number 101. Or we can perform the 2s complement directly. For example, if we have some number 11010. So if we want to perform the 2s complement of this number directly, we have to start from the right hand side and we have to copy the bits as it is up to the first one. That means we have to start from right and we have to copy the bits until we get the first one in our digits. So in 11010 we will get the first bit, first one at this place. So after getting the first one in a code, we have to take the ones complement of the rest of the bits, that is 100. Up to this first one, we have to copy the bits as it is. After that, we have to take the ones complement. So that's how we can convert any number into a 2s complement directly without taking the ones complement and adding the 1 into it. Now, what is the range of the sign magnitude, ones complement and 2s complement? We have to see it from this table only. Like for sign magnitude representation, 0 in binary 0, 0, 0, 0. Again, 0 is same for sign magnitude, ones complement and 2s complement. For 1, 0, 0, 0, 1, this sign magnitude is 1, ones is 1, 2 is 1. That means up to this 0 to 7, that means these are positive because here MSB weight is 0. So for positive numbers, the MSB weight should be 0. So from 0 to 7, the MSB is 0. So the sign magnitude, ones complement and 2s complement, both, all three are same. Because for positive numbers, sign magnitude representation, ones complement and 2s complement, all three are same. We not need to check ones and 2s complement of the positive numbers because all three are same for the positive numbers. Now from 8 to 15, the MSB weight is 1. That means from 8 to 15, the sign magnitude, ones complement, 2s complement, all three are different. Since the MSB weight is 1 and 0, 0, 0 is 0, so it will be -0 because MSB is 1. For 0, 0, 1, the binary is 1 but the MSB is 1, that's why it will represent the -1. And for 0, 1, 0, it is 2, but since MSB is 1, it will equivalent to -2 and so on, -3, -4, -5, -6 and -7. And if we will take the ones complement of this, we will get these numbers, and for 2s complement, we will get this number. So how we can find out the range of the sign magnitude? Here we can see that sign magnitude is gone up to 0 to 7 and from -7 to -0. So the range of sign magnitude is from -7 to +7. For ones complement, again the ones complement is go from 0 to 7 and from -7 to -0. So its range again from -7 to +7. But for the 2s complement case, for positive numbers it will go up to 0 to 7, but for the negative number it will go up to -8 to -1. So the lowest value is -8 and highest value is +7. So the range of the 2s complement number is -8 to +7. Next topic is binary subtraction. Using the, first I will explain the direct method. Like 0 minus 0 is, difference is 0, borrow is 0. 0 minus 1, I will discuss this case earlier. First 1 minus 0 is, difference is 1, borrow is 1. And 1 minus 1 is, difference is 0, borrow is 0. But for 0 minus 1, since we are subtracting the higher number from the lower number, but this is not a -1 in the binary form, because this is a binary, not decimal. So how we can perform 0 minus 1? To perform 0 minus 1, we have to borrow 1 from the previous. So if we will borrow 1, this is equivalent to 2 and this is equivalent to 1. So 2 minus 1 is 1. That means sum is 1, difference is 1 and borrow is 1. This is a difference is 1 and this is a borrow. So for 0 minus 1 case, the difference is 1 and borrow is 1, because we have to take a borrow from the previous number. How we can perform the subtraction using the binary ones complement form? Like if we are having some number in the form of x minus y, then if we are performing the subtraction using the ones complement, then it will become x plus ones complement of y. That means any negative number, if we are taking a ones complement of it will represent a positive number. That means instead of performing the x minus y, we can perform the x plus ones complement of y. So there are certain rules that we have to follow for the subtraction using the ones complement. In subtraction using ones complement, if carry is generated, answer is positive, and to get the final answer we have to add this carry again back to the result. Second point, if carry is not generated, answer is negative. That means to get the original answer we have to again take the ones complement of the answer. This is the same thing that I have discussed earlier. A minus b can be written as a plus ones complement of b. So for example 20 minus 10. So I can write it like 20 plus ones complement of 10 if we are using the ones complement form. So the binary of the 20 is, 2 to the power 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. 2 to the power 4 is 16, so 1 should be here. 2 to the power 2 is 4, so 1 should be here, rest of the bits should be 0. So this is a binary of the 20, 1 0 1 0 0. And binary of the 10 is 1 0 1 0. Since there are 5 bits, so we can add the 0 here, just to make the equal number of bits. So now we have to take the ones complement of the 10. So ones complement of the 10 will become 1 0 1 0 1. So this is the ones complement of the 10. Now we have to add 20 and ones complement of 10. So 20 is 1 0 1 0 0 and ones complement of 10 is 1 0 1 0 1. Now if we are adding these two numbers, we will get 1 0, 1 plus 1 is sum is 0, carry is 1, 1, 1 plus 1 is sum is 0, carry is 1. As we can observe that carry is generated in the final result. So in the previous slide, if you are observing, if carry is generated, answer is positive. That means this answer is positive and we have to add that carry again back to the result. That means this one should be added in these 5 bits. So the final result is 0, 1, 0, 0, 1. If we add this carry, it will become 1 plus 1 is 0, carry is 1. So this is 1, 0, 1, 0. And the binary equivalent of this number is 10. And 20 minus 10 is 10 only. So we are getting the correct result. Now if we are subtracting the higher number from the lower number, then how we can perform? So again we can write 10 minus 20, 10 plus 1's complement of 20. So the binary of the 10 is 1, 0, 1, 0 and the 20 binary of the 20 is 1, 0, 1, 0, 0. Now we have to take the 1's complement of 20. 1's complement of 20. So if we will take 1's complement of this 20, we have to replace 0 with 1 and 1 with 0. So this is the 1's complement of the 20. Now we have to add these two numbers, 10 plus 1's complement of 20. So the binary of 10 is 1, 0, 1, 0. 1's complement of 20 is 0, 1, 0, 1, 1. If we are adding these two numbers, we will get 1. 1 plus 1 is sum is 0, carry is 1. 1. 1 plus 1 is sum is 0, carry is 1. Since there is no carry generated, and if we are seeing in the previous slide, if carry is not generated, answer is negative. That means if we want to get the original answer, we have to take again 1's complement of the result. If we are taking the 1's complement of this, we will get 0, 1, 0, 1, 0. This is equivalent to minus 10. That is what we have to get it from here. 10 minus 20 is equal to minus 10. That means our answer is correct. Now, how we can perform the subtraction using the 2's complement? Earlier we have seen the subtraction using the 1's complement. The method is same. We can convert x minus y into a x plus 2's complement of y. And the rule are also kind of a similar. If carry is generated, answer is positive. But in 2's complement, if carry is generated, we have to discard that carry. If carry is not generated, answer is negative, as in the case of 1's complement, and we have to take the 2's complement of the this negative number. So how we can perform the subtraction using 2's complement? If we are taking the same example, 20 minus 10, so it can be written as 20 plus 2's complement of 10. So the binary of 20 is 1, 0, 1, 0, 0. And binary of 10 is 1, 0, 1, 0. Now we have to take the 2's complement of 10. So if we are using the direct method, we have to copy the bits up to we will get the first one, that is here. Then after that we have to take the 1's complement, that is 1, 0, 1. So this is the 2's complement of 10. Now we have to add 20 and 2's complement of 10, that is 1, 0, 1, 1, 0. 0, 0 plus 1 is 1, 1 plus 1 is 1, 0, that is 1 carry. 1, 1 plus 1 is 1, 0. Since carry is generated, that means answer is positive. But in 2s complement, we have to discard this carry to get the final answer. Whereas in 1's complement, we have to add this carry again back to this result. But in the case of 2s complement, we have to discard this carry. So our final result is 0, 1, 0, 1, 0, which is equal to 10. If we are taking this example 10 minus 20, so we have to perform 10 plus 2s complement of 20. So the binary of 10 is 0, 1, 0, 1, 0 and binary of 20 is 1, 0, 1, 0, 1. Now if we have to take the 2s complement of this, so up to first one we have to copy the bits as it is. After that we have to take the 1's complement. So this is the 2s complement of 20. Now we have to add 10 and 2s complement of 20. So 0 plus 0 is 0, 1, 1, 1 plus 1 is 1, 0, that is 0 is sum, 1 is carry and 1. Since here no carry is generated, so in 2s complement if carry is not generated, the answer is negative. And to get the final answer, we have to take the 2s complement of the final result. So we have to take the 2s complement of this result. So up to first one, the bits should be same. After that, we have to take the 1's complement. So which is equivalent to minus 10. So 10 minus 20 is minus 10. We are getting our correct result. So that's how we have to perform the subtraction using 1's complement and 2s complement. So that's how for this today's lecture. We will continue in the next lecture. Thank you all.